This is an example from the practice exam. So we are given a circuit with a battery connected to a load resistance. The question is, what is the current in the circuit and what is the terminal voltage if we know the load resistance, the EMF, and the internal resistance? Well, from the circuit we see that this side of the terminal of the battery is positive, this is negative, so the current is flowing from a higher potential to a lower potential, like that. Well, first, we know that these 2 points, let's call them V1 and V2. We know that V2 is bigger than V1, so when we say terminal voltage, what we actually mean is the difference between V2 and V1. Okay, so let's write down the key equation. So first of all, we know that the current in the load resistance, according to the Ohm's law, is equal to delta Vt over R. On the other hand, we also know that the EMF is equal to delta Vt plus IR, where R is the internal resistance. So if we want to calculate for current, what we can do is this. We can substitute for delta Vt from here. So delta Vt is equal to EMF minus IR. And on this side, we know that delta Vt is equal to IR. So we can say IR, that's coming from here, equals EMF minus I small r. A simple algebra then shows you that current is equal to the EMF R plus small r. Let's substitute for the values. So EMF is 12 volt. Load resistance plus the internal resistance is 2.2 ohms. And this gives you, так, здесь надо будет отрезать, 5.45. 5.45 amps and 10.9. And this gives you 5.45 amps. Using the currents, we can now calculate for the terminal voltage, which is IR. So 5.45 times R, which is 2, and you get 10.9 volts.